Welcome to Control System lecture series. In this lecture, we are going to concentrate on concept of transfer function and problems on finding the transfer function for a given electrical network. These are the main topics we are going to cover in this lecture. That is, first one is the concept of transfer function, and second one is the derivation of transfer functions for different control systems, and third one is the problems on finding the transfer functions from given electrical systems. Coming to concept of transfer function, it is defined as the ratio of Laplace transform of output of the system to the Laplace transform of input of the system by considering the initial conditions are 0 or by considering the initial conditions are negligible. This is the concept of transfer function. Now we are going to derive the transfer functions for different control systems. Those are open loop control systems and closed loop control systems. In last class we have discussed regarding types of control systems as well as differences between open loop and closed loop control systems. I think no one having doubts in those topics, right?
Yes, sir.
Okay, thank you. Okay, in this class we are going to discuss about concept of transfer function as well as we are going to discuss some of the problems on the concept of transfer function. Okay, first try to get the concept of transfer function. That is, coming to definition of transfer function. Is there any idea regarding definition of transfer function? Okay, no problem. Very simple concept. Coming to definition of transfer function, it is the ratio of Laplace transform of output. Ratio of Laplace transform of output of the system to the Laplace transform of input of the system by considering initial conditions are negligible. Okay. Am I audible?
Yes, sir.
Yes, sir.
Yeah, it is defined as the ratio of Laplace transform of output to the Laplace transform of input by considering the initial conditions are negligible. Means we are going to consider initial conditions are 0. Okay, initial conditions are 0. Okay, this is the simple formula for transfer function. That is, transfer function is equal to Laplace transform of output to the Laplace transform of input by neglecting the initial conditions. Here I is nothing but initial conditions. I is equal to 0 means initial conditions are 0. Now by considering the block diagram, we are going to define the transfer function. Just consider a system, any system which is having some amount of input and also having the output. Here consider input is R of t. Let input of the system consider R of t. Similarly, output of the system consider C of t. And this is the system. Okay, according to definition, obtain the transfer function to this system. Isma, what's the formula for
C of
transfer function?
T by
Yeah,
R.
Laplace transform of
C of
C
T
of T by
C of
R of
T
T.
by R of T.
yeah, R of T.
C of t by R of t, right?
Yes, sir.
Yes, sir.
That's wrong. That's wrong. Okay, here
Laplace trans
input. Yeah, good. Here R of t
Laplace
as well
transform.
as C of t are in time domain, ma'am. Here Laplace transform gives the S domain, frequency domain. So here input and output are in time domain. So transfer function for this block diagram is given as Laplace transform of output. That is nothing but C of t.
C of T.
Yeah. By the Laplace transform of input.
R of
That
t.
is Laplace
R
transform
of
of
t.
R of t. What's the Laplace transform of C of t? Yes, na Laplace transform just converts time domain to frequency domain. Na. So Laplace transform of C of t becomes the C of S. C of t becomes C of S. Ma. And R of t becomes the R of S. Okay, this is the transfer function of this system. Here also we are going to consider initial conditions are 0. Okay, this is the concept of transfer function. That is, it is defined as the Laplace transform of output to the Laplace transform of input of a system by considering initial conditions are 0. Okay, this is a simple representation of a system which is having the input is R of t and output is C of t. Okay, for this system, while forming the transfer function, that is transfer function is equal to Laplace transform of C of t, that is output, to the Laplace transform of input. Here C of t is the output in time domain. Okay, by applying Laplace transform, we are going to get the output in the frequency domain, that is S domain, that is C of S as well as R of S. Here also we are going to consider initial conditions are 0. Esma, is it clear?
Yes, sir.
Yes, sir.
Okay, man, thank you. Now we are going to obtain the Laplace transforms for, that is transfer functions for different types of control systems. Ma. Okay, very basic concept. Ma. Okay, this is the transfer function of, this is just, okay, this is just open loop transfer function of open loop system. Okay, now we are going to make the transfer function of closed loop system. Okay, next one is the transfer function of closed loop system. I think everyone know the block diagram of closed loop system, right? Closed loop control system. Okay, for obtaining the block diagram of closed loop control system, first consider the block diagram of closed loop control system. Okay, this is just block diagram of closed loop control system. What are the major components in closed loop control system?
Mm,
Error detector, feedback.
Input, output, feedback.
Process,
Feedback,
feedback,
input, output,
input,
processor,
out.
or plant.
Yeah, very good. That is, first one is the input, second one is output, and third one is the controller, fourth one is process or plant, then error detector, feedback, and disturbances. Those are the major components of closed loop control system. Okay, here we are going to consider the block diagram of closed loop control system. Okay, this is a simple block diagram. Okay, here controller as well as plant both are going to combine. We are going to represent those two blocks by a simple block, single block, and consider input of this system is R of S. Directly we are considering the in Laplace domain. Okay, consider R of S is the input, C of S is the output, and consider H of S is the feedback ratio. Okay, H of S is the feedback ratio. Then forward gain consider as G of S. This is G of S. and here feedback signal, consider B of S, B of S, and error detector generates the error. So consider the output of this error detector is E of S, E of S. Okay, these are the parameters of closed loop control system. Closed loop control system. Now we are going to obtain the transfer function of closed loop control system. Okay, in bracket consider negative feedback system. Negative feedback system. Okay, the meaning of negative feedback system is we are going to subtract this feedback signal from the reference signal. So here consider this is the minus. That's the meaning of negative feedback system. Okay, now for this block diagram, we have to obtain the transfer function. Okay, simple derivation, ma. No need to worry. Okay, first consider. Okay, first consider this block, ma. The value of g of s. What's the value of g of s here? Yes, ma. Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, this is the block which is having the output is C of S and input is E of S. Okay, input for this
E of
block is
S.
E of S.
E
So
of S.
G of S is given as output to the input. That is C of S by R of S. C of S by R of S, and consider this is equation number 1. C of S by R of S or E of S?
E of S.
Yeah.
E of
Yeah.
Yeah, sir.
Yeah, good ma. E of S. Okay, this block gain is given as C of S. C of S by E of S. That is G of S is equal to C of S by E of S. Consider that is equation number 1 ma. Okay, if any confusion, try to ask me ma. Okay, similarly find out the feedback ratio. Okay, this is the feedback ratio now. What is the HFS? In the similar way of this one, H of S having the output is B of S and input is C of S, right?
B of S by C of S.
Yeah, very good ma. That is H of S is equal to B of S by E of S. B of S by E C of S.
E of S.
Yeah. From that find out B of S. What's the B of S from this equation?
T of S into H of S.
Yeah, good ma. That is
H of S
C
into
of
C of S.
C of S into H of S or H of S into C of S. Both are same. And consider that is equation number 2. H of S. Consider this is equation number 2. Okay, similarly find out E of S. What's the E of S here?
C of S by G of S. C of S.
E of
R
S I am
of
asking.
R of S plus B of S by G of S by R of S plus C.
G of S by R of
E.
S. Okay. Okay, good ma'am. Here E of S is the error signal from this one ma'am. This is not a gain. This is the summing point, right? Okay. The R of S is going to added here and also B of S is going to subtracted from this R of S. So E of S is the R of S minus B of S. In case of G of S, and H of S. Okay, these two are the gains. That's why we are considering the output by input. But in case of this one, this is the summing point. Okay, at this point, two signals going to summed up. That is, this is R of S is adding to this point, summing point, and B of S is subtracted from this R of S. So E of S is given as E of S. Esma, is there any confusion?
No, sir.
E of S is equal to R of S minus
B of S.
R of S minus B of S. B of S. Very simple now, only two steps. Okay, we know B of S value. Okay, from equation number 2, what is the B of S?
H
C
of
of
S
S
C
into
of
C
minus
of
S.
S.
C of S. C of S.
Yeah, in place of B of S, just substitute this one. So substitute B of S from equation number 2. Then we are getting R of S. R of S minus C of S into H of S. C of S into H of S. Okay, from equation number 1, what is C of S?
G of S
G of S
into
G of S
S
into E of S.
E of
Yeah,
S.
just in place of C of S. Substitute this value. From equation number 1, we are getting C of S is equal to G of S into E of S. That value you are going to substitute in place of C of S. So we are getting R of S,
Minus
yeah,
H of
minus G of S
C
into
of E
G,
of S.
G of S into E of S.
E of S into
H of
H of S. Very simple derivation. H of S. Okay, this is the E of S. Okay, from in this equation, in the left hand side, also in right hand side, we are having the term E of S, right? Okay, here this is the E of S, and in this also we are having E of S. So take E of S as the common. By taking E of S as the common, what is the resultant? What is the resultant, ma'am?
1 plus C of
R of
C of S into H of S.
to 1.
Yeah, 1 plus G of S into H of S. G of S into H of S, that is equal to R of S. That is equal to R of S. Okay, only one step is there, ma. Okay, from that we can find out E of S. From this equation, E of S is equal to R of S by this thing now. R of S by 1 plus G of S into H of S. Yes, ma'am, am I clear up to this point?
Yes,
Yes,
sir.
Yes, sir.
Okay, now nothing is there, ma. After finding E of S, just substitute that E of S in equation number 1. We'll get output by input. Okay, from that, what is the E of S value? E of S is
R of
equal to
R
R
of
of
S
S.
by 1 plus G of S into H of S.
Yeah, R of S by 1 plus G of S into H of S. Now consider that is equation number 3, ma. H of S, consider that is equation number 3. Now substitute equation number 3 in equation number 1. Okay, by substituting equation number 3 in equation number 1, we are having equation number 1, that is g of s is equal to,
C of S by
yeah, g of s is equal to c of s by e of s. We are able to see the screen.
Yes,
Yes,
sir.
sir.
yes, sir.
But I am not getting no screen missing ma here. Yeah, yeah. H of g of s is equal to c of s by e of s,
Of
right?
S, C of S.
C of s by e of s. Okay, in this we know C of s is the output. Okay, from this we can write C of s is equal to G of s into E of s. C of s is equal to G of s into E of s. Okay, from equation number 3, what is E of s? Okay, in
R
place
of S
of
by
E of
1 plus
s.
G of
1 plus G
H
into
of
H.
Good now. That is, this is G of s as it is, and E of s is nothing but
R of S by
R
1
of
plus G of S.
R of s by 1 plus G of s into H of s. 1 plus G of s into H of s. What's the transfer function? Input Laplace transform of input by Laplace transform
out,
of output by input now.
output by input.
Yeah, for a closed loop control system, we know C of s is the output ma here. C of s is the output and R of s is the input. Okay, for obtaining the transfer function of this block diagram, we have to find out C of s by R of s, right? Okay, now observe this one, ma'am. This equation. Is there any possibility for getting C of s by R of s?
Yes, sir.
Yeah, from
Yes,
that we
sir.
can write C of s by R of s. That is C of s by R of s is equal to,
G of S by 1 plus G of S into H of
yeah,
S.
yeah, very good, ma'am. That is the transfer function of negative feedback control system. G of s by 1 plus G of s into H of s. G of s into H of s. Okay, this is the derivation of transfer function of negative feedback control system. Is there any confusion now? Okay, once again
No,
I'm
sir.
going to repeat
Yes.
now. Listen carefully. Okay, transfer function of a negative feedback control system. Okay, for obtaining transfer function of negative feedback control system, just consider the block diagram of closed loop control system. Okay, this is the block diagram which is having R of S is the input, C of S is the output, H of S is the feedback ratio, G of S is the gain ratio, and B of S is the feedback gain ratio. And here E of S is the error signal. Okay, by using this block diagram, first to find out the G of S. G of S is nothing but output to the input. That is ratio of output to the input. That is G of S is equal to C of S by E of S. Consider that is equation number 1. Similarly, find out H of S. H of S is equal to output of this block. H of S is B of S and input is C of S. That is H of S is equal to B of S by C of S. Okay, from that find out B of S. B of S is equal to C of S into H of S. Consider that is equation number 2. Similarly, find out E of S. E of s is the subtraction of B of s from the R of s. That is E of s is equal to R of s minus B of s. From equation number 2, we know the B of s. So in this equation, substitute B of s value. So we are getting E of s is equal to R of s minus C of s into H of s. Similarly, from equation number 1, we know C of s value. That is G of s into E of s. Okay. In place of C of s, substitute that value. Then we are getting this one more. R of s minus G of s into E of s by H of s. Okay, here we are having E of s, here we are having E of s. So by taking E of s as the common, we are getting this thing. Okay, from that E of s is equal to R of s by 1 plus G of s into H of s. Okay, consider that is equation number 3. Similarly, we are going to substitute equation number 3 in equation number 1. Okay, by substituting, we are getting this thing. C of s is equal to G of s into E of s value is this one. R of s by 1 plus G of s into H of s. We know transfer function is nothing but Laplace transform of output to the Laplace transform of input. So by taking R of s to left side, we are getting G of s by 1 plus G of s into H of s. Okay, this is the transfer function of negative feedback control system. Negative feedback control system. Is there any confusion, ma'am?
No, sir.
No, sir.
Okay, ma'am. Good. Good, ma'am. Okay, similarly, we are going to obtain the transfer function of positive feedback control system. Okay, next one is the transfer function of positive feedback control system. Positive feedback control system. What's the difference between positive feedback and negative feedback, ma'am?
Here the ratio will be negative, sir. Negative. G of s by 1 minus G of s into H of s.
Yeah, very good, ma'am. Okay, that's the difference. Okay, by keeping that note, we are going to draw the block diagram. Okay, everything depend upon the block diagram only. Okay, first consider the block diagram. Everything same in the block diagram, but while taking the error signal, there is a small change, ma'am. Okay, negative feedback means reference signal and feedback signal going to subtract, but in positive feedback, okay, this is the reference input signal. Okay, from output we are going to apply the feedback signal. This is B of s. Okay, here B of s is going to adding to the input signal. So here we are going to take the plus now. In the negative feedback, here we are going to take the negative, but in positive we are going to take the positive here. And again this is the E of s, and this is the gain, that is G of s, and this is the output, that is C of s, and we are going to take some amount of output which is fed back to the input, and this is the H of s. Okay, in control system we are having so many derivations, ma'am. So we have to write everything. It takes time, ma'am. Okay, this is the block diagram representation of positive feedback control system. Okay, in this also we have to find out G of s. What's the G of s?
C of S by E of
C of S by E of S.
Yeah, good ma. C of S output by input of that block. C of S is the output and input of that block is E of S. Okay, from this equation find out C of S ma. What's the C of S from this one?
G of S
G of
into E of S.
Yeah, good ma. G of S into E of S. Consider that is equation number 1. Okay, try to complete the derivation now. G of S into E of S. Consider this is equation number 1. Okay, similarly find out H of S. What's the H of S?
B of S by B of S by C of S.
Yeah, good man. That is B of S by C of S. H of S is equal to B of S by C of S. From that we have to find out B of S, right?
S, sir.
Yeah, all steps are same, ma'am, but only difference is positive and negative. Okay, from that what's the B of S?
C of
H
S
of S
into
into C of S.
Yeah, C of S into H of S. Consider that is equation number 2. What's the next step? What you have to find out?
E of
E of
S.
S.
Yeah, good ma. E of S. What's the E of S value?
R of S plus B of S.
Yeah, good ma. That's the difference ma. In previous case, we take E of S is the R of S minus B of S. But in this case, we have to take E of S is equal to R of S plus B of S ma. Why? Because this is the positive feedback. Previous one is the negative feedback. Now everything is same. That is from equation number 2. In place of B of S, substitute equation number 2 ma. What's the resultant?
E of S is
R of,
equals to R of
S plus C of S
R
into H of S.
to H.
yeah, good ma. In place of B of S, you have to substitute this one. That is C of S into H of S. C of S into H of S. Again from equation number 1, we have to substitute C of S value. Okay, this is the C of S. Okay, from equation number 1, we know C of S, that is G of S into E of S. Finally, we are getting R of S plus,
Plus G of S into E of S into H.
yeah, G of S into
Into
E
Of
of
S
S
into H.
into H of S.
H of S.
H of S. Again, take E of S as common. Very simple derivation. Okay, this is the E of S. Now take E of S as the common.
E of S into 1 minus H of S into G of S.
Yeah,
It's
very
to R.
good. Okay, by taking and simplifying, we are getting E of S. E
E
of
of
S
S
is
equals
equal
to
to,
R of S by 1 minus H of S into G of S.
yeah, good. R of S by 1 minus,
H of S into G of S.
yeah, 1 minus G of S into H of S or H of S into G of S. Consider that is equation number 3. What's the next step? After finding E
G
of
of
S,
S equals to C of S by E of S.
yeah. Now we have to substitute equation number 3 in equation number 1.
1.
Yeah, directly substitute equation number 3, that is E of S in equation number 1 in place of this E of S now. Then we are getting C of S is equal to,
G of S into R of S by
yeah,
1 minus G of S into H of S.
yeah, G of S into R of S by,
1 minus
yeah, 1 minus
G of
G
S
of
H
S.
into
of S into G of S.
Yeah, H of S into G of S now. Okay, from that,
C of S by R of
C
S
of S
equals
by
to
R. By
yeah,
R
we
of
have
S
to
equals
find
to
out transfer function.
function
Transfer function is nothing but output by
C of
input.
input.
That is C of S is
S
C of S by R of S.
R of S equals to G of S by 1 minus G of S into H of S.
Yeah, very good. Ma. C of S by R of S is equal to G of S by 1 minus G of S into
G
H
of
of S.
S into H of S.
This is the transfer function of positive feedback control system.
Positive feedback control system.
Yeah. Only difference is this one. Ma. If you consider negative feedback control system, transfer function is given as G of S by
G of
1
S by
plus
1
G of
plus
S into
G of
H
S
of
into
S.
H of S.
But in case of positive feedback, we are getting G of S by 1 minus G of S into
1
H of
minus G
S.
of S into H.
Yeah, these two derivations are very important. We have to remember this formula. Yes, ma'am, am I clear or any doubts?
Yes, sir.
Clear, sir.
Clear,
Okay,
sir.
good, good, ma'am. Now make a note. Okay, derivation is clear now. We have to answer these 2 points, ma'am. Okay, these two note points are for gate purpose now, very important. Okay, first one is transfer function of, first point is transfer function of unity feedback control system. Control system, that to negative feedback. That is transfer function of a unity feedback control system. What's the meaning of unity feedback? Okay, very
One
simple
sir.
concept.
One.
Yeah, H of S value is there now. That is feedback ratio H of S. That you have
Is
to
equal to
consider. That you have to consider unity ma 1. Okay, by considering H of S is equal to unity, we have to obtain the transfer functions for negative feedback as well as positive feedback control systems. For a negative feedback control system, what's the transfer function?
G of S by 1 plus G of S. 1 plus
Yeah,
G of
good.
S into
Just
H
you
of
have to consider H of S is equal to 1. That is G of S by 1 plus G of S. 1 plus G of S. This is for negative feedback control
Negative
system.
feedback.
Similarly, go for positive feedback.
G S
Transfer
by 1
function of,
minus G of
G of
S
S
by
by
1
1
minus G of
minus G of S.
yeah, good. Transfer function is equal to G of S by 1 minus G of S. Okay, you have to remember these two formula. Okay, very important in objective as well as gate point of view. G of S by 1 minus G of S. Okay, simply here unity is nothing but unity feedback,
H
that is feedback gain, h of s have to consider unity, that is 1. Okay, this value you have to substitute in the transfer function of positive feedback control system as well as negative feedback control system. By substituting in negative feedback control system, we are getting the transfer function is g of s by 1 plus g of s. By substituting in positive feedback, we are getting transfer function is equal to g of s by 1 minus g of s. Yes, ma'am, am I clear?
yes, sir.
Yes, sir. Yes, sir.
Okay, shall we go for problems based on this formula?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yeah. Okay, first problem. Okay, in this we are going to obtain the transfer functions for a simple electrical networks. Okay, electrical network means it is a network consisting of passive elements and active elements, right? I think everyone know what is passive element and what is active elements. Fine.
Yes, sir.
Okay, go for first problem. Find the transfer function for a given electrical circuit. Find the transfer function for a given electrical circuit. Okay, simple circuit, man. I'm going to give the simple circuit. Okay, that is simply combination of resistor as well as capacitor. Okay, these two elements, these two passive elements going to supplied by a DC source. And the value of this DC source I'm going to consider as EI of t. EI of t, that is input energy source. EI is nothing but input energy source. Similarly, this is the resistance and this is the capacitance. And current flowing through these two elements I am going to consider as I of t. I of t. And consider output across the capacitor. Output considered as E naught of t. Okay, simple electrical network. For this network, we have to find out the transfer function. Okay, it is simple series RC network, which is having the current is I of t and input energy source is EI of t and output voltage we are going to measure across the capacitor. Okay, the transfer function of this one is, what's the transfer function, man? That is Laplace transform of output.
By
Input.
Yeah, Laplace transform of output by Laplace transform of input. Okay, we have to find out this one. Okay, first to find out the input voltage. How can you find out input voltage? That is EI of t. We require EI of t now. We require this value now. How can you find out this value? Okay, man, nothing is there. Just apply KVL to this circuit. What's the KVL equation?
I1 T into R means E naught T
Yeah,
equal to
I1T, that is drop across resistor. Drop across resistor plus drop across capacitor. Drop across capacitor is nothing but voltage across capacitor. What's the formula for
E
voltage across capacitor?
1 by C into 1 by C
Integral
integration of
I
I
do.
of
I square into dt.
I into dt. That is 1 by c integral I dt. That is equal to E1 of t, Ei of t. Okay, this is in time domain now. We require the Laplace transform of this entire thing now. So just to apply Laplace transform to this equation. Okay, first step is apply KVL to the loop. Second step is apply Laplace transform to above KVL equation. This is the first step, and in second step apply Laplace transform to above equation, that is equation number 1. What is the Laplace transform of I of t?
I of
I of
s.
S.
Yeah, good. I of s. What's the Laplace transform of resistor? Okay, Laplace transform of resistor is
R by
resistor
S.
only. Okay, that's the duality property, ma. Okay, Laplace transform of resistor is resistor only. So Laplace transform of this term I of t becomes I of s, and Laplace transform of r is r. Plus, what is the Laplace transform of integration? 1 by c is the constant, ma. What is the Laplace transform of integration?
IT.
Hmm? 1 by s now. That is integral
SL.
of I of t means I of s by s. Okay, once you go through the basic Laplace transform formula. Okay, Laplace transform of integral I of t is I of s by s. Is there any terms here for applying Laplace transform? Okay, we apply Laplace transform for first term as well as second term. That is equal to Laplace transform of ei of t is nothing but ei of s.
Yes.
Yes, ma'am, am I clear or any confusion? Yes, ma'am, am I clear?
Yes, sir.
yes,
Yeah.
sir.
Okay, from that take I of s as the common one. That is ei of s. Ei of s is equal to, by taking I of s as common, we are having I of s into r plus
R plus 1 by CS.
1 by cs. Okay, consider this is equation number 2. Equation number 2. So this one is completed. Laplace transform of I of t is completed. Now we have to determine the Laplace transform of E naught of t. Okay, here what is E naught of t? E naught of t is the output
Output.
now. Output voltage. We are going to measure the output voltage across this capacitor, right? So what is E naught of t? Yes, ma'am, am I clear? We are going to measure the output voltage across this capacitor only. So this E naught of t is nothing but voltage across this capacitor. So E naught of t is equal to voltage across capacitor, that is Vc. We know formula for Vc, voltage across capacitor. What's the formula? 1 by
1
c
1
by
by
into
C
C.
integral
integration of
I
I
of
d.
t into dt.
Into d.
dt. This is in time domain now. But we require in frequency domain now. This is E naught of t in time domain. We require in frequency domain or S domain. For getting the frequency domain or S domain, just apply Laplace transform to this equation. Very simple concept, ma'am. Consider this is equation number 3. Now just apply, that is, this is third step ma. In fourth step, apply the Laplace transform to equation number 3. Apply Laplace transform to equation number 3. What's the Laplace transform of E naught of t?
E naught of
E
S.
naught of
E naught of
Yeah, E naught of s. Similarly, what's the Laplace transform of integration? Again, I of s
1
by
by 1 by
by x.
1
I
by
of
S.
C.
Yes.
I of s by cs.
Yes.
Okay, consider this is equation number 4 ma. Now clearly observe ma. We got the required equations. That is, for obtaining the Laplace transform, we require the, that is, for obtaining the transfer function, we require Laplace transform of output. From equation number 4, we got the Laplace transform of output, right? Similarly, Laplace transform of input. From equation number 2, we got the Laplace transform of input. Now, what's the next step? The transfer function of electrical network. Yeah, transfer function of electrical network is equation number 4 by equation number 2 ma. Transfer function of electrical network, that is equation number 4 by equation number 2, that is E naught of s by E I of s. Okay, substitute and simplify ma. What we are going to get? I of s and I of s gets cancelled. Okay, we are going to get 1 by
R
1 by
CS
CS into
by
1 plus
R
CRS.
plus 1.
yeah RCS ma. Okay, finally we'll get this thing ma. E naught of s by EI of s is equal to 1 by 1 plus RCS. Okay, just a simplification ma. Okay, this is into, I think. Any confusion ma? Or everyone got the same answer? Any confusion in simplification?
Yes.
Okay, nothing is there ma. Okay, that is E naught of s. What's the value of E naught of s?
IS by C of S.
I of s by C of s.
Yeah, I of s by C of
K
s.
into
Same ma. Good ma. I of s by
K
C
into
of s. Okay ma. Similarly, EI of s. What's the value of EI of s? I of s into
R plus
R plus
1
1
by
by C.
yes.
R plus 1 by CS. Okay, just to do the simplification. Okay, here I of s and I of s gets cancelled. Then take the LCM. By taking LCM, we are going to get C of s is the upper part. This C of s is here, and
R
LCM
into
of this
CS.
is 1 plus RCS. Again, CS and CS gets cancelled. That is control system going to cancel. Okay, CS and CS gets cancelled. So finally we are getting 1 by 1 plus RCS. Still any confusion now?
No.
Okay, ma, thank you. Okay, shall we go for one more? Okay, I will give the small electrical network, ma. Try to find out the transfer function. Okay. Okay, note down the electrical network. That is simply series RLC network. Find the transfer function for a given electrical network. The given electrical network is this one. Okay, I'm going to verify the derivation of, that is solution of this problem. Fine. This is your second electrical network. Again, input is EI of T, and this is R L C, and we are going to find out the output voltage across the capacitor, that is E naught of T. Okay, this is for your practice now. Try to practice, and if any confusion, we'll discuss in the next class now. Yes, ma'am, am I audible?
Yes, sir.
Yes, sir.
Yes.
Okay, this is your second network for finding the transfer function. Simple RLC network. Okay. Okay, this is about today's class.